Right. I think last day, Pute, we discussed about functions, procedures, both, right? Are we only about the functions? So this is what I have given last week. We discussed about both, right? Functions and procedures. Yes or no?
Yes, sir.
Right. Okay. So let's proceed from that. I think now today we have to do the theory part. Then the balance is actually the theory part. So since we have finished our coding part, so today's lesson will be a little bit of boring due to theories. But anyway, we have to finish theory part as well. Actually, in this part, we are going to learn about so different programming methods, or we call programming paradigms, different approaches of programming. We call them programming paradigms. And also we are going to learn about the translators, different translators, okay, here, this part. And also how different programming language generations evolve. Actually, this part I just discussed before we start. At the beginning of the coding session also I discussed, but let me revise. I know that. So this was like 11 days ago, not 11 days actually, when you calculate, it is 2 months ago. Therefore, some students might not remember this status. Therefore, I would like to remind this and start. Anyway, we learned in the logic gate lesson, as well as the number system lesson, we learned that, so the basic to the computer is the input basic is the switch and the output is the bulb. So those were the bases, and you need anyway the wires, bulb, switches. Those were the basic. Before anything, the bulb invented. So today the monitor is created using series of bulbs, and switch is similar to the keyboard and mouse. So different inputs that we give. Anyway, switch has two status. You can see on, off, on, off, on, off, on, off. These are the two status that a switch has. It can turn on, turn off, turn on, turn off. Based on that, based on the intermediate circuitries, maybe diodes, condensers, resistors, transistors, according to their behavior, the output is decided. Here in this switch, when you turn on the switch, bulb will turn off. When you turn off the switch, bulb will turn on. So it is similar to a NOT gate. Turn off, turn on. Turn on the switch will turn off the bulb, and turn on, turn off the bulb will turn on the switch. So it is NOT gate behavior. So likewise, different circuits behave different way. So anyway, how do we instruct to these machines? So basically, switch has two status, on off. Bulb has two status, on off. The wires also got two status, that is send in power or not send in power. Basically, to represent these two status, we use binaries. Actually, machine language or the machine understandable language is not binary. That is incorrect, right? Machines cannot understand binary even, but machines can understand electricity. Machines can understand on-off signals. It can understand the power, electricity. So bulbs can understand that. That electricity status are represented, that electricity status are represented using ones and zeros. Therefore, machine language is not binary, but machine language can be represented in binary, and that is the first format of the programming language. You can see 1010. Hello, Mr. Computer, you can ask that, but the computer will understand that a series of these 1 zeros. Actually, these 1 zeros are representing the status, series of electronic status, on off status, or present absent status, or switch on, switch out, off, or maybe power, no power status. So that is what it can understand. So that is called the machine language. It is machine dependent, right? Here you can see few circuitries are there. So you can see the when you turn on, this will turn off, turn off, this is not gate. But the same thing if I do with this switch, nothing happens. On and off will not affect this. එකක් on off කරාට මේකට affect වෙන්නේ. If I turn on, turn off, it is not affecting this bulb. If I turn on, turn off, not affecting the bulb. But if I turn on the both, it is affecting. This is AND gate behavior. Some other way of, so same thing, turning on, turning off, but different behavior. This is another machine. It's like another machine, another behavior. This is another machine, another behavior. You can see both switches are given the response. So 0 will off, on will on. Here also 0 will off, on will on. So both, if I try, yes. Either, that's also, both are off, then off. That is OR gate behavior. So this is another machine. This is another machine. This is another machine. Different machines are like different machines are having different codes. So we can tell the machine language is what it is represented, right? So binary numbers are used to provide instruction. No, this is wrong, right? Binary numbers are used to represent the instructions provided. So that is the correct way of telling. Because binary numbers, computers cannot understand 1 0. No way, right? But it can understand what is represented using this 1 and 0. Computers වලට එක බිඳුව තේරෙන්නේ නැහැ පුතේ. වයර් වල එක බිඳුව යන්නේ නැහැ. Wires can understand the electricity presence and absence. So anyway, whatever we represent using 1s and 0s in binary can be understood by computer in its machine language. Right? That's why I said this statement is wrong. The binary numbers such as 0s and 1s are used to provide instructions, actually used to represent the instructions, used to represent the instructions. These instructions are provided using electricity. Right, anyway, this is very fast because machine can understand it now. It's very fast. It can be directly executed. It is fast. It is no translation needed. So self-explanatory, no translation because machine can understand. And it is machine dependent. Why? Different machines will behave different way according to the different signals. So that is machine dependent. And that is difficult to understand by us. Why? Why is difficult? There should be reason. The reason is that, okay, let's say this is a binary and somebody says, okay, this is similar to, okay, let's say when somebody says this is similar to, if it says this message says the computer to turn off. How come? So can we understand this? No. Oh, this message says computers to the computer to add 2 digits. How come? How can we understand? So we can understand this as 1s and 0s. But if somebody says, this is only example, this is hypothetical, this is not true. This is not true. This is hypothetical. Hypothetical means assumption, right? So this is not really correct thing. This is hypothetical scenario. But still, if somebody says, okay, this message says the computers are 2 digits. How come this? How can you understand? So it is, that's why I said it's difficult, because it has no sense. Unless if you thoroughly study the machine language, you won't understand what's going on. And another thing, this is, if you go and give the same code to another machine, it might not work because it is machine dependent. Machine to machine you have to, and next thing is programmer is responsible, right? Next very important thing, programmer is responsible to maintain the machine. Programmer, he was responsible to maintain machine hardware. Wow. Therefore, very few programmers were there. Why? People, they don't like to take responsibility to the machine hardware, right? So this was another problem in this machine language. So there were very few programmers, as they had to like maintain the machine. They had to go and fix the errors. They have to fix the issues if they want to write programs. They had to be responsible toward this hardware platform. Therefore, very few programmers are interested in doing coding in the machine language, which is the first generation. Okay, you can write down these extra points. So write down the heading, what? The programming language generations. The machine language was considered to be the first generation. Machine language is first generation. So these are the additional things. The messages, it was really difficult to understand what this message is really. And the next problem is, even though you understand this properly, the next problem is that you have to be responsible towards the machine's hardware, which is really big responsibility. If the machine broke, right, then you have to repair. So imagine the machine size. The machine size is like a large building. Machine size is like a large building. කැඩුනොත් හදන්නත් ඕන program ලියලා. හරි. එහෙම වෙලා තියෙනවා. So just search about how first computer bug discovered. Go and search in the internet. Not now. Maybe after the lesson, you can just go and search how the first computer bug was discovered. Okay, I'll show you because this is something interesting. I have actually explained this before even. So the first computer bug, actually that was discovered by a programmer. Bug means error basically. Bug means an error. But what has happened, this programmer wrote a program, right? What has happened actually after he wrote this program, the machine went off. It was not functioning. So the programmer had to maintain. This is in 1947, right? The 1947, what has happened? The programmer need to fix that. මෙයා program එකක් ගිහලා run කරන machine එක කැඩෙනවා. Then what? The programmer had to go and maintain that. So when he was finding the error, he found that in between a switch, there was some insect. He thought it's a bug. Switch දෙකක් මැද්ද හිර වෙලා ඉන්න පොඩි සතෙක්. හිතනවා bug කෙනෙක් කියලා bug මකුණේ. So he want to remove that bug. So we call debug now. Still we call that work, right? Bug is a program error. Debug means fixing that error. Detecting and fixing. තාම අපි වචන කියනවා නේද? Bug is a program error. Debug is detecting and fixing it. Actually, what he has done, he removed the bug, debug, so the machine was functioning. So that is reported to be the first programming bug which is discovered in 1947. Actually, it was a moth, right? It was a moth in relay. In between a switch, there was a moth. පුංචි සමන්ල සලබේක යා හිර වෙලා ඒ හින්දා තමයි මේ මැෂින් එක කැඩිලා තියෙන්නේ. Right? So that was the first programming bug anyway. So that story is really relevant. That's why I just said. Okay, Budhe, can you write down this quickly as an additional note there about the machine language, the first generation language, where the people were responsible to maintain the machines, as well as this machine language, which was really difficult to understand, was used. Okay. Okay. So let's move to the next part. That is assembly language. Assembly language was kind of interesting, the next or the second assembly language. Why? The reason is, so assembly language is a short format of writing a machine language. So in the assembly language, short codes, something like this, add R1, R2, add content of register 2 to register 1. So this is kind of instruction, which was, this is example, right? So this is example, register 1, register 1. This is kind of example which was given in the assembly language. The second generation language was assembly language. Please write down the second generation assembly. And under that, actually, this is sample instruction. This is sample instruction. It is anyway understandable. At least we can read and understand. So, but the thing is still it was machine dependent. Machine to machine, this code was changing. This is depending, machine dependent code. Machine to machine, it was depending. And actually, it is a short format, so it was little easy to understand that than the previous, and little slower than the previous. Why? The reason is it needs something in the middle, a translator. Okay, let's say I'm speaking Sinhala and I have a Japanese friend and I need to communicate with Japanese friend, but he don't know about Sinhala and I also don't know about Japanese. Then what I have to do? I have to find a person who knows both Sinhala and Japanese. Then I can talk to the person. Let's say I'm Sinhalese and I'm talking in Sinhala, and intermediate person will translate my Sinhala language. Oh, my ugly text. Sorry. He will do the translation T part. He will translate my Sinhala language to Japanese language where my friend can understand Japanese. So that is what a translator does. So which is written in this will be converted to this. It will be converted to this. What is this? That is done by the translator, that is assembler. Assembler does the translation. Therefore, it was slow, but was easy to write the program because at least you can understand something. Something is better than nothing. In the machine language, nothing was understandable, but in this, something was understandable that is better than nothing. Okay, the programmers were encouraged a little. Right, programmers were interesting since it was understandable. The programmers were interested in writing codes. Unlike the first generation, this is something better because the programmers were at least interested in writing some programs in assembly language. But still machine dependent. That is the bad side of this. And slow. Still machine dependent and slow. Okay, finish. Let's go to the third category. The third category of the language is high-level programming languages, which was even more convenient to write the program, understandable and easy. What we learned in our lesson, the Pascal belongs to this high-level language category. So you can see, so what if I give you binary, this kind of language to write programs to the computer? Imagine the difficulty. You cannot even understand the code. So how can you write the code, right? So, but it's not like that. You learn very easy language. Even the Pascal, Haskell, these things were easy to understand and it's working in the top level. And it is machine independent. You don't want to worry about the underlying hardware devices. If you write a program in MacBook, it might work in the Windows. If you write a program in Linux, it will execute in Windows even. So it's like that. So you don't want to worry about the underlying layer. So it was working in any platform. So we call platform independent. And it might at least work with same platform, different machines. You write in P1, P2, maybe dual core, quad core, still it will work. So that is something better, no? Right? The machine, it was not machine dependent, machine independent. Right? The machine independent, but need a translator. Right? It needs a translator to translate this language to assembly and then to the machine, the binary code. So we need translators. There are two types of translators. Can you remember this? There are two types of translators. Yes. There are two types of translators. What are they? Okay, these translators are called compilers and interpreters. So assembly is one translator, we already learned. And there are two translators, compilers and interpreters, that is in page number 49. So please write high-level language translators as the heading and interpreter and compiler. So I'll give very short note, easy to remember note. Interpreter translates one statement at a time. If an error, it will stop. Do the translation always when we run the code. So I'm not giving any, I'm not preparing any notes, but here for this part, I would like to give you this note. That's why, okay, let me add this to end of your note. So you can write down the same thing. High level programming language translators. The first one is compiler, sorry, interpreter. The second one is compiler. Compiler, translate everything at once. Faster. Will not execute partial codes as if an error, it will stop full compiling process. But interpreter can run. So let's say, so there are 10 lines of code. The 5th line, there is an error. So interpreter will run first 4 lines. Right? Interpreter is that's slow, right? So I have given everything as a summary. Interpreter is slow. Let's say 10 lines of code. Line 10 code එකක් තියෙනවා. A code has 10 lines. Interpreter can still, it can translate, let's say 5th line, there's an error. So it will execute first 4 lines. But if a compiler does the translation, if the compiler does the translation, so then what will happen? The compiler will compiler will also detect the error. So 5th line, there's error. So compiler will stop entire translation. It will not translate simply. Therefore, you can't run the first 4 lines even. line අතර run වෙන්නේ නැහැ. මුළු program එකම stop වෙනවා. So compile is faster, but interpret is slower. Interpreter is mostly used in translating scripting languages. Scripting languages means scripting languages are languages having less independency and working on some other platform such as web browser or web server. You can get the help of browser or server. Get the help of browser or server by scripting. Programming languages are more independent and run on its own platform. It is mostly compiled, but interpretation can also be there. Mostly compiled, but there can be interpretation too. Java-like languages are interpreted and compiled. Scripting languages, you can say PHP, Python is scripting, VB scripting, JavaScript, programming languages, Java, Pascal, C, C++, C#, VB.NET, so programming languages, right? Even Python can be used as a programming language. These are the scripting and programming language differences. Please write down this part as well. Quickly write down this.